So here's an example of using the integral tables for something which is fairly basic. So I picked the integral of sine of u du. And our calculus textbook gave us this formula. Some of the other tables gave us these formulas. My integral calculator gave me this sort of format. And here's another one sort of showing you. Now, I do want to highlight a couple of differences between these before we move on to some other stuff. So first of all, the more general ones have this extra factor here of ax, as opposed to this one was just u. And it doesn't really matter whether it's an x or a u, that's not the difference. It's whether or not there's the factor of a. So this one basically assumes that a is equal to 1. And if you were to solve this with a equals 1, you get the same sort of solution there. The other thing is whether or not it tells you explicitly that you have some plus some constant of integration. Now, if you're using this form, what you need to remember is that you have to evaluate it at your boundary conditions. So let me take that sort of solution here. If I've got the integral from, say, a to b of sine of u du, I've got minus cosine of u, but then I have to evaluate it from a to b, which means I've got minus the cosine of b, and subtract from that minus the cosine of a. So that constant of integration is if I don't have specific boundaries, but if I do have specific boundaries, I actually have to evaluate it at those boundaries. Now, you could go through and simplify this a little bit because you've got a negative and negative, so it's the value of cosine at a minus the value of cosine at point b. Before I move on to another example, I want to go ahead and pull up not just the table of integrals, but the integral calculator, and show how we could actually work with this one in these different forms. So let's say we've got an AU in there, and then I'm going to actually evaluate it from 0 to B. Or let's just keep things the same as I had before and make this a factor of C in there. And so you can set it up actually using the type of values that you've got. Once this looks like it's the way that you want it, then you can go ahead and hit go, and it will show you what's there to be calculated. And so it gives you this form, and with the definite integral, it actually goes through and gives you the full version of that. And it can be written out or it can be simplified, depending on which way you look at it. One of these might be more simple. Now, they can also have here, if I think about the integral, if I want to have values in here, I could take it from, say, 0 up to some other value, 3, and it shows me that what I'm really doing the integral here is it's showing me that area under the curve. So it might give you just a little bit more of a understanding of what it is you're doing as you do that calculation. Now, when it goes through here with the manual, it actually does have these show the steps, and it can talk about, okay, if I've got CU, well, I do a variable substitution, and therefore I work things out, and it's going through and doing that. So that's something that you can see here as one example of using an integral calculator or using the integral tables to show what we have going on.